Hello students, welcome back. In today's class, we are discussing about diode as a rectifier. Now, rectifier is a device which converts AC into DC source. So, there are two types of rectifier. First one is half-wave rectifier. This circuit over here, this circuit is known as a rectifier circuit. Now, this input, this is the first starting point. This is the input, which is the AC. That is alternating current, and alternating current varies like this. It is during 0, it will be at 0, it will increase slowly, and at half time period t/2 it completes half cycle, and t it completes full cycle. So this is an AC input which goes to a transformer. This part is a transformer. This is a step up transformer. Now from this step up transformer, it goes into the diode, and from the diode it goes into the resistance RL, which is also known as load resistance, and there will be output. Now how this works, let us discuss about how this actually works. Now in the first step, what happens is, during the first cycle, first positive cycle, over here what you can see is, in the first cycle, this is towards the positive side. So during the first positive cycle, voltage at A, let me write this point as A. Okay, the voltage at A will be positive. So if voltage at A is positive, and this side is P side, and this is N side of a diode, so positive and positive, what happens? Diode is in forward biasing, or diode is forward biased. At forward biasing, what happens? Diode will conduct current. It will conduct current. So during the first positive cycle, it will conduct current, and I'll just draw the output somewhere here. During the first positive cycle, it will conduct current. So you can see a cycle like this. Now, during the second negative cycle over here, during this cycle, which is towards the negative side, in the second negative cycle, here in the second negative cycle, what happens is, this A will be negative, and when A becomes negative, this is negative, P side is positive, negative and positive, what happens? Diode is in reverse biasing or reversely biased. And reverse biasing, there will be no current, so it will conduct zero current. So during reverse biasing, the current will be 0. So this point, instead of going down, the current will be 0. This is T. This is in one cycle. So in the next cycle, again A will be positive. So the cycle will look like this. Then in the next cycle, A will be negative. This will look like this. Similarly, this will keep on happening. So this is the the amplitude will remain the same. This is the output of half-wave rectifier. The output is unidirectional, and it is a rectified output, which means that frequency of input and frequency of output is the same. So frequency remains the same. So this is what happens in a full wave rectification or a full wave rectifier. In many solid state equipments or a solid state semiconductor devices, direct current of low voltage is required. In that case, a step down transformer is used in a rectifier. So in place of step up transformer, if you want lesser amount of voltage in the output of low voltage, then a step down transformer is used to decrease the voltage. If a step up is used, then what happens? The voltage will increase. So this is what happens in a half wave rectifier. Now the next one is full wave rectifier. In a full wave rectifier, there is an input which is connected to a step-up transformer, and there are two diodes used in the circuit. This is diode 1, or this is D1, another is diode 2, this D2. Now the diode is connected to RL. This RL is a resistance used as load. So whenever we get a voltage at output, that is we get in a controlled manner. That is the function of this load. So now what happens over here, we'll just see one by one. Now the input, okay, the input is again a sinusoidal wave. So the input is a sinusoidal wave. So I'll just draw the diagram at this side. So what happens during the first cycle is, during first positive cycle, okay, during this positive cycle, let us consider again this point as A, okay, and this point as B. So during first positive cycle, this side will be, A will be positive and B will be negative. So when A is positive, this is side is P side and this is N. Again this is P and this is N. Positive and positive will be, that means during first positive cycle, A will be, or D1, diode D1 will be forward biasing, and diode D2 over here, this is negative, so this is positive, this D2 will be reverse biasing. So in forward biasing, it will conduct current, and it will in reverse biasing, it will not conduct current. So the output, if this is the input, the output is like this. This is for diode 1. This output is for diode 1. So for diode 1, if it is conducting, it will look like this, okay, in the first cycle. Now for D2, this one will be for D2. If it is not conducting, then it will be like this. Okay, now this is in the first cycle. Second, what happens? This A will be, in the second cycle, A will be negative, B will be positive. So if A is negative, this side is positive, D1 will be reverse biasing, D2 will be forward biasing. Okay, just the opposite. So now D1 will not conduct and D2 will conduct current. So the wave, now in the second cycle, D1 will not conduct, D2 will conduct. So this continues. Okay, this continues. And in the output, in the ultimate output, the cycle which we get is, this is when D1 is conducting, again this is when D2 is conducting, this is again D1 is conducting, this is D2, this is D1, D2, D1, D2. This is when 0, the cycle is 90 degree, then 180. Similarly, it will keep on increasing. Okay, this is the ultimate output of the full wave rectifier. So this is how a rectifier works. Okay, the output is a continuous series of unidirectional pulses. So the output is a continuous series of unidirectional pulses. So this is the output. Okay, this is the working, and you need to draw this diagram, and whatever I have told you working also you need to write down. Now next is special type of junction diodes. So the special type of junction diodes, first one is LED light, that is light emitting diode. The bulb which we use in our house is actually diode, a semiconductor device diode, and it is light emitting diode. So it is a device which emits light when a current is passed through it in a forward biased condition. So it works on a forward biasing condition. That means P is connected to positive and to negative. So when current flows through this circuit, this will emit light. It will radiate. That is how a LED works. Now the thing over here is P side is thin so that light energy can reach the charge depleted region. So if there is P side and N side, so the P side is thin, very thin. So what happens? When the current is flowing, it can easily pass through the P side and reach the depleted layer which is there in between. P side and the inside, between there is a depleted region. So P side is thin. When an electron hole recombine, then an equal amount of energy is released in the form of photon. So whenever this electron and hole they combine, when electron and hole they combine, they release energy in the form of photon. So the frequency which is being released is directly proportional to the energy released, and intensity is directly proportional to the number of photons. So intensity of LED depends upon the number of photons which is being created after electron and hole combination. The advantage of LED is, first one is unlimited lifespan due to absence of filament. We don't have filament in this bulb, so what happens? There is unlimited lifespan. An LED requires small amount of power and voltage, and the size of LED is also very small. That is the advantage. The application is, it is used in our household also. You know how LED can be used. So the working of LED, applications and advantage, to remember, that is frequently asked in the examination. Okay, this is the first type. Now the second one is photodiode. The photodiode, the circuit of photodiode is also similar. Now this is the circuit of a photodiode. It is a receiver of optical signals. Okay, this is a receiver of optical signals. So whenever light falls into this, okay, whenever we get any optical intensity, anything, light kind of things, then it gives signal. Over here, N side is large. In this one, N side is large. So N side has more electron. So it has more electron. And this works on a reverse biasing condition. Small current known as reverse saturation current or leakage current flows in the circuit. Because it is working on a reverse bias condition, current will be very, very small, known as leakage current. The current is due to the drift of electron-hole pair which are thermally generated. Now the advantage of photodiode is, it is used to get a quick response to light, to detect visible and invisible optical signals. So photodiode is basically used to detect the UV or any visible and non-visible optical signals. Not UV, all the signals, all the optical signals that is being received, that can be detected by a photodiode. So this is the second type of a special type of a junction diode. The third type, which is there in the syllabus, is a solar cell. Now the third type is a solar cell. This is very common and you know how it works. Now solar cell is also a diode. It is unbiased. Unbiased means it is not connected to any external source. But what a solar cell will do is, solar cell will generate electricity. So whatever electricity is being generated is being stored in a battery. So this battery is to collect the electrical energy. Now it is unbiased, designed in such a way that it can convert sufficient percentage of light energy falling into the electrical energy. It is also known as photovoltaic cell. Okay, it's also known as photovoltaic cell. Now what happens over here is, most of the light sunlight falls on this surface. So surface of the P side and N side is large. It is a large kind of a flat surface. So light falls on the P side. From your hole will move to the N side. Because it's very thin, it will be easier for hole to move towards N side. And whenever they combine, electricity will be generated and the battery will charge the electricity. Now the application you already know. Solar cells are used to recharge batteries for satellites. Okay, that is one of the main important application. And solar cells are used to charge batteries, which in turn gives us the power. So it's not the solar cell which is directly giving the power. It is used to charge the battery. In turn, the battery will give us the power. So this is how a solar cell works. Okay, so for this chapter we have already completed these 3 topics and we have completed the chapter as well. So in the next class I will be starting a new chapter. Thank you.